Now welcome everybody to this latest A2 video on trigonometry, and in this video we'll be continuing with harmonic form with a focus on finding maximum and minimum values. Now a bit of warning, the sound quality of this video is not great, very echoey and does feel like as if you're being taught by a Dalek. Now often you may get asked what the maximum and or minimum value of an expression in harmonic form can be and the value of theta for which the maximum or minimum value exists. Now if we take a closer look at an expression that is in harmonic form, so for example it's either going to look like this or like this. Now in terms of knowledge that we know from both the cos graph, which looks like this, and the sine graph, which looks like this, then we can see that the maximum value this cos theta plus or minus alpha can be is going to be plus 1. So the max that this can be is going to be equal to 1, and the minimum this can be is going to be equal to minus 1. And similarly for the sine theta, that the maximum this part can be is equal to positive 1, and the minimum it can be is minus 1. So therefore the maximum value that an expression of, let's say in harmonic form relating to cos, is going to be, so the maximum value is going to be positive r, and the minimum value is therefore going to be minus r. And again, the reason for that is because if we look at those highlighted parts, so this, the maximum that can be is plus 1, the minimum it can be is minus 1, so therefore the maximum value of the expression is going to be positive r, the minimum value is going to be minus r, and the same thing goes for sine. So again, the maximum the sine theta plus alpha can be is positive 1, so therefore the maximum value of the expression is going to be positive r, and the minimum value that the expression could take is going to be minus r, because technically we are then going to be multiplying it by minus 1. So to find the value of theta for which the maximum value can take, or the minimum value can take, is to make the cos theta plus or minus alpha equal to 1, or the sine alpha plus or minus 1 equal to 1, where alpha has already been worked out in the prior example. So here we're going to have a number instead of alpha, and so all we need to do is to find for what value of theta that value exists for, is just make this whole bit equal to 1, or if we're working with sine, to make this all equal to 1, and then go on to solve it like we've done when we looked at solving trig equations in AS. And similarly for when to find values of theta where that gives us the minimum value, then all we need to do is substitute our alpha value in, and then solve this if we're working with cos, or we solve this when we're working with sine. So r has no relevance at all to finding out what the theta value is for our maximum value. Now if that failed to make any sense to you at all, hopefully by going through some examples, hopefully it should make a little bit more sense to you. So let's have a look. So the first example says, or the first part should say, says express the function with respect to theta equals 2 sine theta minus 3 cos theta in the form of r sine theta minus alpha, where alpha is between 0 and 90. So for the first part, for part A, this is just very, very similar to just getting it into harmonic form. So in terms of this now, typically with a bit of practice, this is about the minimum amount of working out you'd need to get into harmonic form. So we know that tan theta is always going to be the sine value over the cos value, or coefficient as to say. So then here we've got that alpha is going to equal 56.3 degrees, and that's to 1 decimal place. Then to find r, well, r squared is basically taking those two numbers squared and working out the sum of those. So it's 2 squared plus 3 squared. So r squared equals 4 plus 9, which is 13, so r equals root of 13. So then writing it into that form will therefore be that equals root 13, and it's going to be sine of theta minus 56.3 degrees, and there is my final answer. Now for part B, the question says, hence write down the largest possible value of the function and state the smallest value for which this occurs. Now, smallest positive value is just missing something in this question of, and let's just stick a theta in there. And so we can make this question look correct. Let's move that up a little bit. There we go. So, in terms of this, then for part B, Let's go through the processes of working this out. Well, for this, in terms of the maximum value, well, the maximum value is when sine theta minus 56.3 is going to be equal to positive 1. So therefore, the max value is going to equal root 13 times 1. So then the maximum value is root 13. Now, in terms of finding theta for when it's going to be root 13, so it's going to be maximum, I can spell it, so maximum when, and that's going to be when sine theta minus 56.3 degrees is equal to 1. So therefore, my next line is going to be, so I'm just put a dashed line to make sure that we're not getting confused between the two things. So here I've got theta minus 56.3 is going to be equal to the inverse sine or arc sine of 1. So theta equals, right, theta minus 56.3 is going to be equal to 90 degrees. And then here, all we then need to do is find out what theta is. So it's going to be 90 plus 56.3. So theta equals 146.3 degrees to 1 decimal place. And there are my two answers for part B. So now let's have a look at our second question. Now this second question might look a little bit strange to you simply because we've got no indication on what harmonic form we want. Do we want r sine theta minus alpha or plus alpha, or are we using r cos theta minus alpha? Now for this, it doesn't really matter which one we choose. We can actually use either. Now just because we use sine in the previous example, I'm going to opt for using cos. Now again, it doesn't really matter. It should give us the exact same answer. So the first thing we need to do is get it into harmonic form. Now again, it doesn't really give me an indication, but again, the fact that this rings a bell means that I'm going to have to do something with it. So again, going for the shorthand version, that tan theta equals, and it's going to be 4 over 3. So theta equals, it's going to be 53.1 degrees to 1 dp. And r squared equals 3 squared plus 4 squared, so r equals 5. So writing in harmonic form, what I've got is I've got that expression is going to equal 5, and it's going to be cos theta minus 53.1 degrees. Now it's always worth just paying attention on this, that if you are using the cos, make sure the symbol at this stage is the opposite of the symbol that's in the original expression, because when you expand this, what you're wanting is your expression, the compound angle formula, to have the same sign as this. Sine, it's always the same, but with cos, it's always the opposite. So just be mindful of that. So now let me just get rid of this. So I've just got a bit more space. So once I've got this in this form, so that's what that equals. I'm going to work out what the minimum value is going to be. Now in terms of this, because I'm wanting the minimum value, so the minimum value is basically when this sine part or the cos part of this part is going to be equal to, so minimum value when cos theta minus 53.1 is equal to minus 1. So when that is, I'm going to have 5 times minus 1. So the minimum value is not going to be square root, so I don't know why I've written that, is going to equal minus 5. And it's always worth highlighting it. Now its minimum is going to be when cos theta minus 53.1 degrees is equal to minus 1. So then working through that, what I then need to do is then know that theta minus 53.1 is going to be equal to the inverse cos of minus 1, or arc cos, whichever you prefer. So theta minus 53.1 is going to be equal to, so I'm looking at the cos graph, I'm looking at where it's minus 1. So cos graph looks something like this. So it's minus 1 there, and it's minus 1 there. So it's going to be minus 1 at plus or minus 180. Now I'm going to write this out long because I need to work out what theta is. So I'm going to write minus 180 and 180. But then I need to find out what theta is. So what I'm going to do is just add 53.1 to each of those. So if I add 53.1, I get 126.9 degrees and 233.1 degrees. Now looking at the range, it's telling me that theta is between minus 180 and 180, so therefore I'm going to discount this one because this is outside the range. And it's always worth just being careful of that. Would you still write the 233.1? Yes, I would, but I would emphasize that this is the only valid answer, whether it be in a separate line or you see that I've crossed out the previous answer, but I've also taken it into account when writing this. And it's always just worth just making sure that your answers are highlighted in some form so it's easy for the person to mark your work.